Chandra X-ray observations of Abell 119 cold fronts and a shock in an evolved off-axis merger. We present Chandra X-ray observations of the dynamically complex galaxy cluster Abell 119. A119 is host to two NAT radio sources whose tails are oriented parallel to each other despite orthogonally oriented jet axes. Imaging and spectral analysis reveal X-ray emission elongated along the Ni-SW axis along with the presence of complex structures, including surface brightness discontinuities, which suggest possible merger activity along this axis. From radial profiles of the X-ray surface brightness, temperature, pressure, and density, we identify two surface brightness edges which are found to be cold fronts, possibly associated with large-scale sloshing of icon gas. We also identify a brightness edge to the south which is found to be a shock front with Mach number m equal to 1.21 pn 0.11, consistent with a merger shock. In addition, previous optical studies show alignment of optical substructures along the north-south direction. The elongated X-ray emission, orientations of the NAT tails, and alignment of optical substructure all suggest recent or ongoing merger activity in the Ni-SW direction. Next article. The 2175 angstrom interstellar extinction bump is the wavelength variable. The most striking characteristics of the mysterious 2175 angstrom extinction bump, the strongest spectroscopic absorption feature seen on the interstellar extinction curve, are the invariant central wavelength and variable bandwidth. Its peak position at 2175 angstrom is remarkably constant while its bandwidth varies from one line of sight to another. However, recent studies of the lines of sight toward a number of Herbig AEB stars have revealed that the extinction bump exhibits substantial shifts from the canonical wavelength of 2175 angstrom. In this work, we revisit these lines of sight and take a physical approach to determine the ultraviolet extinction curve for each line of sight. It is found that the wavelengths of the derived UV extinction bumps are around 2200 angstrom and the scatters are considerably smaller than that of the previous study based on the same set of Herbig AEB stars, consistent with the conventional wisdom. Nevertheless, the scatters are still appreciably larger than that associated with the nominal bump position of 2175 angstrom. This is discussed in the context that Herbig AEB stars are not well suited for interstellar extinction studies. Next article. Mach Observatory 2000 light cone Mach catalogs of luminous red galaxies from the Hyper Subprime Cam survey for the cosmological large-scale analysis. Estimating a reliable covariance matrix for correlation functions of galaxies is a crucial task to attain accurate cosmological constraints from galaxy surveys. We generate 2000 independent light cone Mach luminous red galaxy catalogs at 0.3 Lec lat 1.25, designed to cover Chimera LRGS observed by the Subaru Hyper Subprime Cam Subaru Strategic Program. We first produce full-sky light cone halo catalogs using a comoving Lagrangian acceleration technique, and then trim them to match the footprints of the HSC SSBS 28-9 layers. The Mach LRGS are subsequently populated onto the trimmed halo catalogs according to the halo occupation distribution model constrained by the observed Chimera LRGS. The stellar mass is assigned to each LRG by the Sapelo abundance matching technique using the observed stellar mass functions of Chimera LRGS. We evaluate photometric redshifts of Mach LRGS by incorporating the photo-Z scatter, which is derived from the observed M-star photo-Z scatter relations of the Chimera LRGS. We validate the constructed full-sky halo and light cone LRG Mach catalogs by comparing their angular clustering statistics with those measured from the halo catalogs of full n-body simulations, and that can be read arxiv catalogs from the HSCSSB, respectively. We detect clear signatures of baryon acoustic oscillations from our Mach LRGS, whose angular scales are well consistent with theoretical predictions. These results demonstrate that our Mach LRGS can be used to evaluate covariance matrices at large scales and provide predictions for the bow detectability and cosmological constraints. Next article. Color transformations of photometric measurements of galaxies in optical and near-infrared wide-field imaging surveys. Over the past 2 decades, wide-field photometric surveys in optical and infrared domains reached a nearly all-sky coverage thanks to numerous observational facilities operating in both hemispheres. However, subtle differences among exact realizations of Johnson and SDSS photometric systems require one to convert photometric measurements into the same system prior to analysis of composite data sets originating from multiple surveys. It turns out that the published photometric transformations lead to substantial biases when applied to integrated photometry of galaxies from the corresponding catalogs. Here we present photometric transformations based on piecewise linear approximations of integrated photometry of galaxies in the optical surveys SDSS, DECALS, BASE, MZLS, DES, DELV, KIDS, VST Atlas, and the near-infrared surveys UPITS, US, VHS, and Viking. We validate our transformations by constructing K-corrected color magnitude diagrams of non-active galaxies and measuring the position and tightness of the red sequence. We also provide transformations for aperture magnitudes and show how they are affected by the image quality difference among the surveys. We present the implementation of the derived transformations in Python and IDLE and also a web-based color transformation calculator for galaxies. By comparing DECALS and DES, we identified systematic issues in DECALS photometry for extended galaxies, which we attribute to the photometric software package used by DECALS. As an application of our method, we compiled 2 multi-wavelength photometric catalogs for over 200 low and intermediate redshift galaxies originating from CFA FAST and Heptaspec spectral archives. Next article. Composite bulges Roman III, a study of nuclear star clusters in nearby spiral galaxies. We present photometric and morphological analyses of nuclear star clusters, very dense, massive star clusters present in the central regions of most galaxies in a sample of 33 massive disk galaxies within 20 MPC, part of the Composite Bulges survey. We use data from the Hubble Space Telescope, including optical and near-Earth images from the Wide Field Camera 3. We fit the images in 2D to take into account the full complexity of the inner regions of these galaxies, isolating the nuclear star cluster and bulge components. We derive NSC radii and magnitudes in all 3 bands, which we then use to estimate NSC masses. Our sample significantly expands the sample of massive late-type galaxies with measured NSC properties. We clearly identify nuclear star clusters in nearly 80% of our galaxies, putting a lower limit on the nucleation fraction in these galaxies that is higher than previous estimates. We find that the NSCs in our massive disk galaxies are consistent with previous NSC mass, NSC radius, and galaxy mass, NSC mass relations. However, we also find a large spread in NSC masses, with a handful of galaxies hosting very low mass, compact clusters. Our NSCs are aligned in PA with their host galaxy disks but are less flattened. They show no correlations with bar or bulge properties. Finally, we find the ratio of NSC to BH mass in our massive disk galaxy sample spans a factor of sim 300. Next article. Aliphatics and aromatics in the universe, the pre-JWST era. The so-called unidentified infrared emission features at 3.3, 6.2, 7.7, 8.6, and 11.3 micron, ubiquitously seen in a wide variety of astrophysical regions, are generally attributed to polycyclic aromatic hydrocarbon molecules. Astronomical PAS often have an aliphatic component, as revealed by the detection in many UE sources of the aliphatic CH stretching feature at 3.4 micron. With its unprecedented sensitivity, unprecedented spatial resolution, and high spectral resolution, the James Webb Space Telescope holds great promise for evolutionizing the studies of aliphatics and aromatics in the universe. To facilitate analyzing JWST observations, we present a theoretical framework for determining the aliphatic fractions of PAS, the fractions of C atoms in aliphatic units, from the emission intensity ratios of the 3.4 micron feature to the 3.3 micron feature. To demonstrate the effectiveness of this framework, we compile the 3.3 and 3.4 micron UE data obtained in the pre-JWST era for an as complete as possible sample, and then apply the framework to these pre-JWST data. We derive a median aliphatic fraction of less than eta Ali greater than equal to 5.4% and find that the aliphatic fractions are the highest in protoplanetary nebulae illuminated by kill stars lacking ultraviolet radiation. Nevertheless, the hardness of stellar photons is not the only factor affecting the PA aliphaticity. Other factors, such as the starlight intensity, may also play an important role. Next article. Examples line lists. Line molecular line list for lithium hydroxide. A new molecular line list for lithium hydroxide covering wavelengths lambda greater than 1 μm is presented. The OIT7 line list contains over 331 million transitions between rotation vibration energy levels with total angular momentum up to J equal to 95 and is applicable for temperatures up to T approx 3,500 K. Line list calculations are based on a previously published high-level texted ab initio potential energy surface and a newly computed dipole moment surface of the ground (x to the power 1 sigma to the power electronic state. Lithium-containing molecules are important in a variety of stellar objects, and there is potential for LEO to be observed in the atmospheres of exoplanets. This work provides the first comprehensive line list of LEO and will facilitate its future molecular detection. The OIT7 line list, along with the associated temperature and pressure-dependent opacities, can be downloaded from the ExoMol database at www.exomol.com and the CDS Astronomical Database. Next article. Polycyclic aromatic hydrocarbon molecules and the 2175 angstrom interstellar extinction bump. The exact nature of the 2175 angstrom extinction bump, the strongest spectroscopic absorption feature superimposed on the interstellar extinction curve, remains unknown ever since its discovery in 1965. Popular candidate carriers for the extinction bump include nano-sized graphitic grains and polycyclic aromatic hydrocarbon molecules. To quantitatively evaluate PAS as a possible carrier, we perform quantum chemical computations for the electronic transitions of 30 compact paracondensed PA molecules and their cations, as well as anions with a wide range of sizes from 16 to 96 C atoms and a mean size of 43 C atoms. It is found that a mixture of such PAS which individually exhibit sharp absorption features, show a smooth and broad absorption band that resembles the 2175 angstrom interstellar extinction bump. Arising from pi to the power star left row pi transitions, the width and intensity of the absorption bump for otherwise randomly selected and uniformly weighted Pol mixtures do not vary much with Pos sizes and charge states, whereas the position shifts to longer wavelengths as Pos size increases. While the computed bump position, with the computational uncertainty taken into account, appears to agree with that of the interstellar extinction bump, the computed width is considerably broader than the interstellar bump, which remains unaccounted for as far as the Pol mixtures considered here are concerned. It appears that, to account for the observed bump width, one has to resort to Pos species of specific sizes and structures. Next article. Radio emission from a Z10-3 black hole in OOS-1. The recent discovery of a 4 times 10 to the power 7 MO. black hole in OOS-1 at Z equal to 10.3, just 450 m after the Big Bang, suggests that the seeds of the first quasars may have been direct collapse black holes from the collapse of supermassive primordial stars at Z Sim 20. This object was identified in James Webb Space Telescope NIRCam and Chandra X-ray data, but recent studies suggest that radio emission from such a BH should also be visible to the Square Kilometre Array and the next generation Very Large Array. Here, we present estimates of radio flux for OOS-1 from 0.110 GHz and find that SKA and NG-VLA could detect it with integration times of 10/100 HR and just 1/10 HR, respectively. It may be possible to see this object with VLA now with longer integration times. The detection of radio emission from OOS-1 would be a first test of exciting new synergies between near-infrared and radio observatories that could open the era of Z-Sim 515 quasar astronomy in the coming decade. Next article. Signatures of massive black hole merger host galaxies from cosmological simulations, i.e. galaxy morphologies in imaging. Low-frequency gravitational wave experiments such as the laser interferometer space antenna and pulsar timing arrays are expected to detect individual massive black hole binaries and mergers. However, secure methods of identifying the exact host galaxy of each MBH merger amongst the large number of galaxies in the gravitational wave localization region are currently lacking. We investigate the distinct morphological signatures of MBH merger host galaxies using the Romulus 25 cosmological simulation. We produce mock telescope images of 201 simulated galaxies in Romulus 25 hosting recent MBH mergers through stellar population synthesis and dust radiative transfer. Based on comparisons to mass and redshift-matched control samples, we show that combining multiple morphological statistics via linear discriminant analysis enables identification of the host galaxies of MBH mergers with accuracies that increase with chirp mass and mass ratio. For mergers with high chirp masses and high mass ratios, the accuracy of this approach reaches greater than 80% and does not decline for at least greater than 1 J after numerical merger. We argue that these trends arise because the most distinctive morphological characteristics of MBH merger and binary host galaxies are prominent classical bulges, rather than relatively short-lived morphological disturbances from their preceding galaxy mergers. Since these bulges are formed through major mergers of massive galaxies, they lead to MBH binaries and mergers that have high chirp masses and mass ratios. Our results suggest that galaxy morphology can aid in identifying the host galaxies of future MBH binaries and mergers. Next article. Effects of massive central objects on the degree of energy equipartition of globular clusters. We present an analysis of the degree of energy equipartition in a sample of 101 Monte Carlo numerical simulations of globular clusters hosting either a system of stellar mass black holes, an intermediate mass black hole, or neither of them. For the first time, we systematically explore the signatures that the presence of BHS or IMS produces on the degree of energy equipartition and if these signatures could be found in current observations. We show that a BHS can halt the evolution towards energy equipartition in the cluster center. We also show that this effect grows stronger with the number of stellar mass black holes in the GC. The signatures introduced by IMS depend on how dominant their masses are to the GCS and for how long the IMP has co-evolved with its host GCS. IMPs with a mass fraction below 2% of the cluster mass produce a similar dynamical effect to BHS, halting the energy equipartition evolution. IMPs with a mass fraction larger than 2% can produce an inversion of the observed mass dependency of the velocity dispersion, where the velocity dispersion grows with mass. We compare our results with observations of galactic GCS and show that the observed range of the degree of energy equipartition in real clusters is consistent with that found in our analysis. In particular, we show that some galactic GCS fall within the anomalous behavior expected for systems hosting a BHS or an IMP and are promising candidates for further dynamical analysis. Next article: Photoevaporation versus enrichment in the cradle of the Sun. The presence of short-lived radioisotopes 26 Al and 60 Phi in the Solar System places constraints on the initial conditions of our planetary system. Most theorists posit that the origin of 26 Al and 60 Phi is in the interiors of massive stars, and they are either delivered directly to the protosolar disk from the winds and supernovae of the massive stars, or indirectly via a sequential star formation event. However, massive stars that produce SLRs also emit photoionizing far and extreme ultraviolet radiation, which can destroy the gas component of protoplanetary disks, possibly precluding the formation of gas giant planets like Jupiter and Saturn. Here, we perform N-body simulations of star-forming regions and determine whether disks that are enriched in SLRs can retain enough gas to form Jovian planets. We find that disks are enriched and survive the photoionizing radiation only when the dust radius of the disk is fixed and not allowed to move inwards due to the photoevaporation, or outwards due to viscous spreading. Even in this optimal scenario, not enough disks survive until the supernovae of the massive stars and so have zero or very little enrichment in 60 Phi. We therefore suggest that the delivery of SLRs to the solar system may not come from the winds and supernovae of massive stars. Next article: Deuterated polycyclic aromatic hydrocarbons in the interstellar medium, the aliphatic CD band strengths. Deuterium was exclusively generated in the Big Bang, and the standard Big Bang nucleosynthesis model predicts a primordial abundance of DH26 ppm. As the galaxy evolves, DH gradually decreases because of astration. The galactic chemical evolution model predicts a present-day abundance of DH20 ppm. However, observations of the local interstellar medium have revealed that the gas phase interstellar DH varies considerably from one region to another and has a median abundance of DH13 ppm, substantially lower than predicted from the BBN and GCE models. It has been suggested that the missing D atoms of DH7 ppm could have been locked up in deuterated polycyclic aromatic hydrocarbon molecules. However, we have previously demonstrated that PAs with aromatic CD units are insufficient to account for the missing D. Here we explore if PAs with aliphatic CD units could be a reservoir of D. we perform quantum chemical computations of the vibrational spectra of superdeuterated Pos and Pos attached with D-substituted methyl group and derive the band strengths of the aliphatic CD stretch. By applying the computationally derived A4.65 to the observed aliphatic CD emission at 4.64.8 micron, we find that Pos with aliphatic CD units could have tied up a substantial amount of DH and marginally account for the missing D. The possible routes to generate Pos with aliphatic CD units are also discussed. Next article. Example line lists for the methylidyne cation. Comprehensive and accurate raw vibronic line lists for the x to the power 1 sigma to the power and a to the power 1 pi states of to the power 12 c to the power 1 h to the power and to the power 13 c to that power 1 h to the power, which should be applicable to temperatures of 5,000 K are presented. Available empirical potential energy curves and high-level ab initio dipole and transition dipole moment curves are used with the program level to compute raw vibronic energy levels and Einstein coefficients. Lambda doubling is incorporated into the energy levels and a coefficients involving the to the power 1 pi state using an empirical method. For to the power 12 c to the power 1 h to the power, line positions are improved by using both laboratory and astronomical observational spectra as input to the Marvel procedure. The to the power 12c to the power 1h to the power line list contains 1,505 states and 34,194 transitions over the frequency range of 0.33,010 cn to the power 1. Comparisons with observed astronomical and laboratory spectra give very good agreement. The KIT-CH to the power line lists and partition functions are available from the EXAML database at www.examl.com. Next article. Galactic outflow emission line profiles evidence for dusty radiatively driven ionized winds in MRK 462. Over the past half-century, gas outflows and winds have been observed as asymmetric emission lines in a wide range of astrophysical contexts, including galaxies and early-type stars. While P-Sydney lines are modeled and understood with physically motivated profiles under the symbol of approximation, asymmetric nebular lines are not. Previous studies of galactic outflows using nebular emission lines have made physically unjustified assumptions about the shape of the line profile. These approaches limit assessment of outflow properties and do not connect observations to the underlying physics. The physical complexity of galactic outflows requires a more robust approach. In response to this need, we present a novel profile for modeling nebular emission lines, which is generalized yet physically motivated and provides insight into the underlying mechanisms of galactic outflows. To demonstrate the usefulness of this profile, we fit it to the asymmetric nebular lines observed in the nuclear region of MRK 462, a starburst and composite galaxy. From analysis of the best fit profile, we conclude that the observed profile arises from a dusty radiation pressure-driven outflow with a terminal velocity of 750 kN/s1. This outflow, while weak by some standards, is still sufficiently strong to regulate star formation and black hole growth in the host galaxy by removing gas from the inner few kiloparsecs. Outflows like the one we observe and characterize in MRK 462 are crucial to our understanding of episodic gas-fueled activity in galactic nuclei, which undoubtedly plays a pivotal role in galaxy evolution. Next article. Analyzing the cosmic web environment in the vicinity of grand design and flocculate spirals with local geometric index. We explore the environment of a combined set of 367 grand design and 619 flocculent spiral galaxies. We introduce a novel estimator called the Texted Local Geometric Index to quantify the morphology of the local environment of these 986 spirals. The local geometric index allows us to classify the environment of galaxies into voids, sheets, filaments, and clusters. We find that grand designs are mostly located in dense environments like clusters and filaments, whereas the fraction of the flocculents lying in sparse environments like voids and sheets is significantly higher than that of the grand designs. A p-value less than 10 to the power 3 from a Kolmogorov-Smirnov test indicates that our results are statistically significant at 99.9% confidence level. Further, we note that dense environments with large tidal flows are dominated by the grand designs. On the other hand, low-density environments such as sheets and voids favor the growth of flocculents. Next article. Field blue straggler stars discovery of white dwarf companions to blue metal poor stars using UV astrosat. Blue metal poor stars are the main sequence stars that appear bluer and more luminous than normal turn-off stars of metal poor globular clusters. They are believed to be either field blue straggler stars formed via post-mass transfer mechanism or accreted from dwarf satellite galaxies of the Milky Way. A significant fraction of BMP stars are discovered to be potential binaries. We observed 27 BMP stars using UV texted astrosat in two filters, F148W and F169M. We report the discovery of white dwarf companions of 12 BMP stars for the first time. The WD companions have estimated temperatures TEFF SIM 10,500 18,250 K and masses 0.17 m ODOT 0.8 n ODOT. Based on pH and space velocity, we group the 12 BMP FBSS stars as the thick disk and halo, whereas two stars appear to be in between. All the 5 thick disk BMP FBSS have extremely low mass WDS as companions, whereas the 5 halo BMP FBSS have low, normal, and high mass WD companions. Our analysis suggests that at least SIM 44% of BMP stars are FBSS, and these stars hold the key to understand the details of mass transfer, binary properties, and chemical enrichment among the FBSS. Next article. NGC 2992 The interplay between the multiphase disk wind and radio bubbles. We present an analysis of the gas kinematics in NGC 2992 based on VLT Muse, ALMA and VLA data aimed at characterizing the disk, the wind, and their interplay in the cold molecular and warm ionized phases. CO and HRM alpha arise from a multiphase disk with inclination 80 dead and radii 1.5 and 1.8 kpc, respectively. We find that the velocity dispersion of the cold molecular phase is consistent with that of star-forming galaxies at the same redshift, except in the inner 600 pc region and in the region between the cone walls and the disk. This suggests that a disk-wind interaction locally boosts the gas turbulence. We detect a clumpy ionized wind distributed in two wide opening angle ionization cones reaching scales of 7 kpc. The Roman 3 wind expands with velocity exceeding 1000 kms in the inner 600 pc, a factor of 5 larger than the previously reported wind velocity. Based on spatially resolved electron density and ionization parameter maps, we infer an ionized outflow mass of mRm of ion equal to times 10 to the power 7 m ODOT and a total ionized outflow rate of .mRm of ion equal to 13.5 pm1 SFR. We detected clumps of cold molecular gas located above and below the disk, reaching maximum projected distances and velocities of 1.7 kpc and 200 kns, respectively. On these scales, the wind is multiphase, with a fast ionized component and a slower molecular one, and a total mass of MRM of ion mol equal to 5.8 times 10 to the power 7 MO, of which the molecular component carries the bulk of the mass. The dusty molecular outflowing clumps and the turbulent ionized gas are located at the edges of the radio bubbles, suggesting that the bubbles interact with the surrounding medium through shocks. We detected dust reservoir co-spatial with the molecular disk, with a cold dust mass MRM dust equal to times 10 to the power 6 MO.